All right, now I know not all of these were in your pair deck, but I think most of them were. I can't remember which one I left out. But as we look through these, you're going to see I've drawn in the angle and the direction in which I rotated. So it's important that as you're looking at these, that you see I started from the positive x-axis and rotated in a positive direction, rotated counterclockwise. So I had to draw that arrow on all of these. Now, 1 degree is very small, right? 1 degree is 1/360th of a circle. I had a hard time drawing something quite that small. It would probably actually be a lot smaller than that. That's probably closer to maybe 10 degrees or maybe 8 degrees. But it's hard to do that with any kind of exact preciseness when you're doing it by hand. 1 radian, so we know that there's 6.28 radians in a circle. 1 radian, just as a good rule of thumb, is about 57 degrees. Okay, so if you're thinking about it, it's just a little bit less than 60 degrees if I'm going to draw an angle that's 1 radian. Pi radians, we know if the whole rotation ends up being at 2 pi, so pi rotations is going to be a half of a rotation, which actually ends up being 180 degrees. So pi radians is also 180 degrees. Now, when you think about pi over 2 radians, actually in the previous example, we looked at that. Pi over 2 radians is going to be a fourth of a rotation because 1 rotation is 2 pi radians. Cut that into a fourth, you have pi over 2. But you can also think of it as half of a rotation or half of 180, so that's 90 degrees. Pi over 4 radians, so that's 1/4 of half of a rotation. So if you think of 1/4 of pi, that's what we're looking at, right? Now, a fourth of 180 is going to give us 45 degrees, and that's how you can figure out what that angle is. Pi over 3 radians, once again, think of it as a third of pi or a third of 180, so that's 60 degrees. And then finally, pi over 6 radians, once again, think of that as 1/6 of pi or 1/6 of 180, which is 30 degrees.